All right. So as always, guys, the guided notes are better than I think my sheet. But since I started doing it with this sheet, I'm going to keep doing it. So what we're going to do here is we're going to open up the equation editor. We're going to type in the h, and then we're going to do our parentheses to get rid of this. So remember, we are multiplying. So what happens here is this becomes, where are we? Oops, I just said I wasn't going to use it. There we go. So if we're doing this one, we're going to do the 1/2. So this becomes 1/2, and we're going to do cosine of 2 theta, or, geez, sorry, too many tabs. 1 minus cosine of 2 theta. All right, it's going to be parentheses 1 minus cosine of 2 theta. Is the theta at? Do that. Do that. And so that 8 and this 1/2 are going to cancel out. And we're going to get, well, they don't really cancel out. We're just really taking half of 8. And then we're going to end up distributing that to the 1 minus cosine of 2 theta. And I really should put parentheses over the argument. You guys can if you want. To me, um, it looks a little cleaner. It's just, well, I'm lazy. There's no other excuse. I'm just too lazy to put it in. So we do 4 minus 4 cosine of 2 theta. And that should be everything that we're doing for here. All right. And then when we go to this one, double angle. So use the double angle formula uh, to verify that sine 4 is equal to this. Um, double angle formula. So we're going to use the double angle formula on this. So this becomes sine. Oh, I think this is the one where I used the wrong formula the last time. We're not going to do that again. What I did last time was I think I did this. I did sine plus that, and that made it this way more complicated than it had to be, especially because they wanted us to use the double angle. So what we're going to do here is we're going to do sine times 2x here. So this, I remember, is a lot easier than the way I did it. It became really complicated when I did the 2x plus 2x because we had to use some formula. They only want us using double angle formula. So looking back, I was like, duh. So in this case, our theta is 2x. We're probably going to have to use some more double angle formulas later, and you'll see why. So give me a second. This one. Okay, there we go. So the double angle formula. So if we're going to do the double angle formula, we're going to go here. So here we're going to put down double angle of sine, right? Double angle of sine. So we're going to do sine theta cosine theta. So this becomes 2 sine. Our theta is actually, I just realized I haven't been doing that. Oh, but we're doing it with x's. So I won't do it with x's because I've already started it. Is 2x. So our theta here is 2x. And do the 2x cosine of 2x. That's our argument again. So I'll put it in the argument thing. So if we look here, we kind of have an issue because, wait a minute, where'd we get all this stuff from? Well, what's happening here is now we have another sign with a 2x. So this ends up being Gonna move this over here. This ends up being 2 times 2. So 2 in parentheses, we're gonna do the rest. I don't know why I put an S there. 2 in parentheses, 2 sine theta. So we're cutting this in half. If it was 2, now it becomes just theta. So this 2x just becomes an x. And then we're going to do cosine of x. All right, and that's all going to get multiplied by this cosine right here. So let me know if I'm going too fast, guys. This cosine right here is going to go next. And what I just finished doing was this right here. All right. So when we're doing this, we're going to use the equation for the double angle formula for cosine. So we have a double angle. We have two options here. We can do the cosine squared theta minus that. So what you would want to do is you would want to pick one that kind of looks similar here. So it looks like we kind of want it to end with cosine times something else. So, oh, actually, look here. This one right here, 1 minus 2 sine squared x, right there. So we do want that last one. So that just changes into parentheses. 2, where is it? Parentheses. 1 minus, oh, I'm going to have to do this in the equation editor. Because I can't do powers without the equation editor. Sine squared, oops, I guess I could have done it that way. Squared x. And we get that here. And that's this right here. I don't know why they cut off this part here. But if I copy this again for the next line, what happens is we're going to multiply this 2 by this. We don't distribute it to everything. We just multiply it by either this or this. So that just means that this 2 turns into a 4. And that's exactly what we were solving for. Does that make sense, everyone? Are you like, that's the most sense I've had this whole unit? And this morning. All right. So this next one, they want us to use the double angle identities to verify this. Is that supposed to be a 2? How do we use double angle identities if that's a 3? Give me a second, guys. Are they being crazy? Cosine theta. The only thing, and I don't want to get out of the line and go all crazy here again. So I'm going to, what are they doing here? Because last time I did this, I used the sum angle formulas, but I definitely don't want to do that if I don't have to. Where's the sum and difference formula? I'm thinking sum and difference here, but I'm afraid that's going to make everything crazy. So let me think. So we have 1 minus 4, and the cosine. I don't really see addition here. So I don't think I'm going to use the sum and difference formulas. I almost feel like that might be a typo, but it can't be. Use double angle identities. It's the double angle formulas. Because the one thing students might want to do when they're doing this is they might want to like you can just do cosine of that, but you can't. I can't see me doing this without the identities. Hold on. I see this here. I'm gonna try to do it that way, guys. Hopefully this works out. So we're gonna try to do this with the sum and difference identities here. Hopefully this doesn't take me down the rabbit hole. You know what? I'm just gonna have Edmentum tell me what they're talking about. Ah, I was right. I called it. Leave it to Edmentum to make me doubt myself. So what's happening here is this first one, we can't use the double angle identity because this is not a double angle. It's a tripled angle. So in order to make it a double angle, what we're going to do is we're going to do the double angle plus the single angle. So that's our first step. Now what we're going to do here is this part, or blah. So now what we're going to do here is we're going to change this part right here to this. This is essentially, we're going over here and we're picking the 1 minus 2 sine squared. The reason why we're doing that is we already see that there's a 1 minus some type of sine squared over here, right? So that's probably a good hint that we want to pick that one. Then you can have a hard time. Clearly, you haven't seen the video before this one because when you pick the wrong one, you get all this work and it should have been easier. All right, so we get this, and the next thing we want to do this sine. Oops, circle too much. We want to do this sine right here. So if we're doing this sine, this double angle of the sine, we're going to look for the double angle. So luckily, sine is easy. Sine has just this part right here, this 2 sine theta cosine theta. So we're going to replace that with this 2 sine theta cosine theta. I don't know why there's a double parentheses here. I guess to remind you to. No, I have no idea why there's a double parentheses there. All right. So now that we have that, why is there a division sign here? Okay, let me. I have a feeling this is a typo and this is supposed to be a parentheses. Hmm. Come on, Edmentum, what are you doing here? So they are failing me. Thank you for that. So we have this. So what they're doing is they're distributing this is what I see here, but what is this? All right, I'm going to take it over from where they left off and see if I can salvage this train wreck. Something's going on and I can't figure it out from how they're doing it. So cosine x minus, I'll put the single parentheses so I don't mess this up like they did. Sine x, cosine x, sine x. Ah, no. I always hate when I do that. I start all big and I'm like, I don't have enough room. And I make it all tiny again. All right, so this, like that. All right, and I don't want to get a single angle, so this becomes cosine x minus 2 sine squared x cosine x minus 2 sine squared x cosine sine. Oh, wait, no, not cosine sine. So I don't know if you guys can see it because I know it crashed out, but this times that is going to square it. We're going to square those signs together. So we end up getting this. So then once we do all this, this becomes cosine x minus 4 sine squared x cosine x, right? Well, if we look at this, this and this share something in common. So they both have a factor of cosine x. So we're going to factor out that cosine x divided by cosine x is 1 minus 4 sine squared x. So I don't know what they were doing over here. That looked really freaking confusing, but this is how you would solve this double angle identity. Does that kind of make sense? Okay, so no, can't prove it. Oh my gosh. Do you really? It took you that long to realize that was in the nook. Not the one that you know. Okay. Well, at least that shows you're paying attention. Better? All right. Uh, so I don't know what they did over there, but essentially what you guys are doing is your goal is always to try to figure this out. So you do have some choices when you're doing the cosine. Always kind of take a look at what they're doing. So I saw this one minus something side squared, and I was like, oh, I'm going to use this one. And for this one, just be like, for this one, honestly, what I would do is like, I didn't know when to use some angle formulas versus not using it. Because on the first one, you saw what happened. It got out of hand really quickly. Like if you guys, uh, Nick and Garrett weren't, you guys weren't here. I super went off on like a really big tangent for this one, and it was not right. Like it was just nope. It wasn't wrong because I followed all the steps. It was just way more complicated than it had to be. Yeah. So let's go over here. So and you can wow. Um. Why do you why do you have a 10 in front of the house? Okay. All right. So one thing that I recommend, guys, if you don't like this because it looks too complicated, when you get to this slide, print this out. Oh, well, the cheat sheet's here, but here's another cheat sheet if you want to use this cheat sheet. You could you could even screenshot it and just have it on another tab when you're taking the mastery test for this. Uh, Anyways, so